We've learned in the past how to calculate the slope of a line by looking at the actual graph of the line. Today we're going to investigate how we find the slope of a line when we are given just 2 points that are on the line. And it's by using something called the slope formula. Let's look at an example. Let's say I give you the points that are on the screen here, -2, -3, and +2, +3. And I ask you to calculate the slope of the line. This is a little bit different because I'm not giving you the actual picture of the line. Think about how you may approach this problem. Hit pause and then hit play when you are ready. So now that you've had time to think about it, hopefully some of you thought that maybe it would be wise to go ahead and take these points and plot them on the graph. So to plot the point -2, -3, we start at the origin, and the -2 means I move 2 to the left. The -3 means I move 3 spaces down, and then I put my dot right there. To plot the point +2, +3, I start at the origin. The +2 means I move 2 to the right along the x-axis, and the +3 means I move 3 spaces up along the y-axis. So now I could connect those and I could actually make a picture of my line. So I could do that. So I've used my line drawing tool and now I have a picture of the line that passes through the point. So now I can use what we've learned in the past. I'm going to count my rise over the run, or the change in the y over the change in the x. Remember, we start with the point on the left-hand side because we go left to right as we calculate the slope. So to go from this point here to this point here, the first thing I do is I'm going to go up. Let's count. 1, 2, 3, 4, 5, 6. The next thing that I'm going to do is I'm going to go to the right. 1, 2, 3, 4. So I went up 6 and then I went to the right 4. So my rise is 6 and my run is 4. And we always want to simplify our slope into simplest form. And so that would be +3/2. So that's one way I could find the slope of a line when I'm just given 2 points, is I could actually just plot the points, draw my line, and then I'm back to finding the slope from the actual graph. So let's use that same idea. What if I give you these 2 points? -723, 59, and +481, -260. Could you do this the same way? Could you plot the points on the graph and then count the squares and calculate the rise over run? If you take some time to think about it, especially looking at the graph that I've provided here, that would be pretty tricky. These numbers are huge. And so that really doesn't make any sense to approach the problem in that way. So what we want to do is we want to come up with another way that we could calculate the slope of a line when we are given 2 points, without having to actually plot the points on the graph and count the squares. So what we're going to do is we're going to figure out a formula that would help us to do it without plotting the points and graphing. So to get an idea of how we could calculate a formula, let's look at this problem that is here on my screen. It says, to find the slope of the graph, Aiden counted the rise to be 6 and the run to be 8. So if you notice here, they're counting by 2s along the y-axis. And so it's going up 2, 4, 6 spaces. And then the run here is 8. So if you put rise over run, 6/8 is equal to 3/4. That's the slope of the line. But let's look at the actual ordered pairs and see if we could find a pattern. So what I'd like you to focus on are these 2 ordered pairs. The 16, 16, which goes with this point here, and the 8, 10, which goes with that point there. If we have these numbers here, the 6 over the 8, let's see if we could figure out a way that they got those. So starting with the y values, how could they have figured out that the rise was 6? Well, since the rise, this 6 right here, since that comes from the y values, what could I do with this 16 and 10 to make it give me this number 6 here in the top? If you said subtract them, then you are right. All I would have to do is subtract the 2 y values 16 minus 10, and that would give me 6. Now, the run here of 8, whoops, sorry, didn't mean to do that. The run here of 8, that comes from the x values, movement left and right. That's the x values. What could I do with those numbers, 16 and 8, to give me this 8 down here in the bottom? If you said subtract, then you are right, because 16 minus 8 gives me 8. So now I think we found a pattern. When I want to figure out the slope and I'm given just 2 points, like, oops, sorry, like these numbers here and these numbers here, what I can do is I can subtract the y values to figure out the rise, and then I could subtract the x values to figure out the run. So all I have to do is subtract the y's and the x's in my ordered pairs. So let's just summarize that a little bit. That is called the slope formula. We know the slope is rise over run. It's really important that you remember that. But our formula is you can take the second y minus the first y in the ordered pairs and put that over the second x minus the first x. Now let me just clarify where those different things, notations and with the variables are coming from. Every ordered pair has an x first and a y second. So I could say that this could be my first ordered pair, so this is my first x, first y. This could be my second ordered pair, the second x, the second y. And so all that we do to figure out the slope is take the second y minus the first y, and that's going to go on top, and then we take the second x minus the first x, and that's going to go on bottom, so that we have this slope formula, y2 minus y1 over x2 minus x1. So let me show you with some examples how this works. So problem number 4 says that we want to find the slope between these two ordered pairs, 2, 4, and 1, 7. Let's use the formula so we don't have to graph it and count squares. So first thing that I recommend that you do is that you label your ordered pairs. So again, this is my first x and my first y, because every ordered pair has an x and a y. This is my second x and my second y. The formula says I take the second y minus the first y, and that would go on top. So I have 7 minus 4. And then what I'm going to do is I'm going to put that over the second x minus the first x. So that would be 1 minus 2. So that's my formula, y2 minus y1 over x2 minus x1. Now we just simplify. 7 minus 4 on the top gives me 3, and 1 minus 2 gives me a negative 1. So I have 3 over negative 1, which is just negative 3. Let's try this again. Problem number 5. Let's label first. First x, first y. Second x, second y. Now we apply the formula. The formula again is the second y minus the first y over the second x minus the first x. I recommend drawing arrows. I think it really helps you to keep track of things. So second y minus the first y. So that part is negative 2 minus 0 over the second x minus the first x. 3 minus a negative 1. Now you have to be careful here. There's always a minus sign in our formula, if you notice, in between the x's and y's. So if the second number after that is negative, you're going to have 2 negatives, as seen in this formula right here. Remember that 2 negatives next to each other equals 1 plus sign. So when we simplify this, negative 2 minus 0 is negative 2, and 3 minus a negative 1 becomes 3 plus 1, or 4. So this gives me negative 2 over 4, and then if you simplify that, your final answer is negative 1/2. Now I want to show you something at this point. If these points were in reverse, and for instance in number 6, let's say I gave you the 5, 5 first and the 1, 3 second, do you think that would give you a different answer? So the answer is actually no. You just have to be consistent in how you subtract. what I've been doing is I draw my arrows. I'm always going right to left. And then I subtract my x's the same direction, right to left. As long as you are consistent like that, you will get the same answer no matter which way you're subtracting or which way the points are placed in order. So be consistent. If you go right to left in your subtraction on the y's, you must go right to left in your subtraction on the x's. You could do it the opposite. You could go left to right, left to right, but just as long as you're doing it the same direction, either way, you'll get the same answer. So let's look at problem number 6 here. You're going to do, first let's label, because I think that helps keep you from making mistakes. So first x, first y, second x, second y. Follow the pattern. Y minus y, 5 minus 3 would be on the top. x2 minus x1, 5 minus 1 would be on the bottom. And then you simplify. 5 minus 3 gives you 2. 5 minus 1 gives you 4. We always put our fraction in simplest form, and 2 over 4 simplifies to positive 1/2. Now see if you can do problem number 7 on your own. There's some decimals in there, but that's okay. We have calculators. So give that one a try. Label the order pairs, draw your arrows, and apply the formula. Hit pause and hit play when you are ready. Okay, so the first thing on number 7 you should have done is labeled x1, y1, first x, first y, x2, y2, second x, second y. The next thing we're going to do is we're going to draw our arrows. We take the second y minus the first y. I'm going right to left, 3 minus 0. Then I'm going to take 3.5 minus 4.25. So 3 minus 0 is on top, 3.5 minus 4.25 is in the bottom. All right, so this gives you 3 over negative 0.75. Now, it is not proper to leave a decimal in a fraction, so go ahead and take your calculator and divide that, and that should end up giving you negative 4. Now go ahead and try numbers 8 and 9, and when you are ready, go ahead and hit play. So problem number 8, I went ahead and drew my arrows, and I did the subtraction, right to left, right to left. So I have 3/4 minus 3/4 over 5 minus 2. Now 3/4 minus 3/4 is 0, 5 minus 2 is 3. 0 divided by 3 is just 0, so my slope is 0. If we were to plot those 2 points, what type of line would that be if the slope is 0? If you thought horizontal, then you are right. Whenever the y values are the same, that's going to give us a horizontal line when we connect those points. Now let's look at problem number 9. So problem number 9, I've labeled and I've drawn my arrows. And now I apply my formula, y2 minus y1 over x2 minus x1. That gives me 2 minus 3 over 7.5 minus 7.5. Now, 2 minus 3 is a negative 1, and then 7.5 minus 7.5 is 0. If you put that in your calculator, what does it give you? If you said error, then you are right. Some calculators will say dividing by 0 error. You can never divide by 0, or 0 can never be in the bottom of a fraction. And so what that is called is undefined. So if you remember this little trick, if you have 0 in the top, it is okay. 0 in the top is equal to 0. If you have 0 in the bottom, that is not okay. And 0 in the bottom is undefined. I'll put UND for short. What type of line would problem number 9 be if the slope is undefined? Well, if you remember, that's a vertical line. The worst possible curse word in math is with a slope of a vertical line. When these x values are the same, if you plot the points and connect them, you're going to have a vertical line, and its slope is undefined. So that is a summary of how we use the slope formula to find the slope of a line when we're given 2 points. Using this formula, we don't have to graph them and count squares. We can just straight apply the formula.